we present tangible actions, a compelling alternative to the standard object action model, well suited for multi-touch tabletop interfaces. In tangible actions, we make actions themselves tangible, giving a new flavor to the idea of direct manipulation. Large multi-touch interfaces are very expressive. However, that means they require more physical effort for repetitive tasks. Here is an example of a user sorting photos from a recent trip. This task is initially fun, but requires more motion than necessary. In another example, this user is straightening photos. While the rotate gesture is initially fun and expressive, it can also get tiring. Tangible actions allows the user to create, modify, and reuse actions for increased efficiency. Here, the user takes advantage of several move actions. And here, the user uses a few rotate actions. Users can create tangible actions by gestures in the background. Once instantiated, tangible actions are continually replaying and apply their action to any object that passes over them. Alternatively, an action may be moved to apply its effect to several objects. By gesturing with two fingers on top of our rotate and scale actions, we can modify their parameters as we apply the action. To preview the result of a tangible action on an object, the user holds the object over the action without releasing it. In tangible actions, we take inspiration from command line interfaces, which have a smooth progression from performing actions to reusing and modifying to scripting. Here is an example of a user arranging furniture in a house. In our system, every user action on an object is recorded. To bring up a history interface, the user places the flat part of their hand down on the table. The user can scroll through the action history using the scroll bar that appears at the bottom of the screen and select actions for reuse. Once in play, several tangible actions can be snapped together to create ad hoc scripts, further improving efficiency. For actions that don't have a corresponding gesture, the user can pull the tangible action off a toolbar. Here, we have a prototype email application. The user examines the subject line of email as it comes in and applies a color and/or star before adding it to a pile. As before, the user can make scripts when they discover they are repeating actions. When the user doesn't need a script, they can simply push it to the side to make space. To deal with dense fields of objects, we present two interaction techniques: inactive drag mode and ad hoc pile spreading. Since tangible actions are always on by default, actions can be unintentionally applied to objects they must be dragged over. When the user double taps on a tangible action, it enters inactive drag mode, where it can be dragged over objects without acting on them. As before, a preview of the action is shown. To apply the action to a single object without leaving inactive drag mode, the user can tap on the tangible action with another finger. Ad hoc pile spreading helps the user apply a tangible action to one object in a pile of objects. When a held tangible action approaches a tight pile of objects, it spreads out perpendicular to the tangible action. As the user moves the tangible action left and right, the spacing of the objects changes so that the object directly in front of the tangible action is easier to access. In the standard model, the user selects the object of interest and the action is executed by interaction elsewhere, such as on a toolbar. Multiple selection allows users to apply an action to a group of objects, either by using a toolbar or by acting on one object as an example. While selection and toolbars work well for small, single-user interfaces, they break down for interfaces that are larger and have multiple users. For even a single user, a fixed toolbar may be far away from the working space. For multiple users, it is difficult for the interface to tell which touch contacts belong to which user. There is currently no implementation of selection for multiple users. Fixed toolbars can also be frustrating for multiple users, as they may need to reach into each other's space. By contrast, tangible actions allow multiple users to apply actions efficiently to objects, without the use of selection or repeated use of a toolbar. When actions are tangible, users are able to work together in novel ways. With the scripting feature of tangible actions, they can even work on separate parts of the same action. We have presented tangible actions, a novel extension of direct manipulation inspired by the flexibility of the command line, and designed for large multi-touch interfaces.